watching Gram Science.
In this video, we will solve A-Levels Chemistry question paper 5-2 of the exam series October-November 22. Question 1 we will discuss in this video, and in next video we will solve the question 2. Along with solving, we will also see the important tips of paper 5, including what are variables, what are the measurements we need to know while solving paper 5, and what are the errors and accuracies we should be taking care, and what is in percentage error and how to calculate it. So here is our first question, which says eggshells contain high percentage by mass of calcium carbonate. A student wants to find out what percentage of an eggshell is calcium carbonate and uses the following method. Now you can always pause the video and read all the steps in detail, but by the time I'll go ahead with the next step. So here there is a reaction. The calcium carbonate in the eggshell reacts with the excess hydrochloric acid as follows, and here is the reaction given. The excess acid reacts with the sodium hydroxide solution as follows, and there is one more reaction here. Now suggest how the student should confirm the eggshell is completely dry in the step 2. Now in the step 2 it says that warm the eggshell in an oven for few minutes until dry. So to confirm that the eggshell is fully dry, how can we ensure? Now the only method is that we should reweigh the eggshell and heat it, and reheat also. I'll better say reheat and reweigh it until constant mass, because that is how we can ensure that all of the water has evaporated out. The next sub question says state why the eggshell is made into powder in step 3 before making up the solution. Explain your answer. Now if we are powdering it in step 3, that shows that we should, so we are just writing to increase the surface area, and hence increase the rate of reaction. That is the main reason that why do we powder a reactant. So here we have powdered eggshell. Now suggest why the solution is left for 2 days in step 6 before being used, and this is to ensure that the reaction is complete. That shows that the whole of the eggshell, or you can say that the all the calcium carbonate inside the shell should fully react. So to ensure that the reaction is complete. And now let's go ahead with the next part of the question, which says student uses exactly 2.136 gram of powdered eggshell and obtains the results shown in table 1.1, and here is our table. Now what is done here? The titration number, final burette reading, initial burette reading, the rough titer is here 0 to 16.55. So our titer again is 16.55 centimeter cube. The first reading, accurate reading, is 32.85 and 16.55. Now we need to find out the difference of this to get the titer. So the difference is 16.30. Again, next is subtracting the second reading, we get it exactly 16.00. And for the third titer, the third reading, the difference is 16.20. Now if we find out the mean of these 3 readings, then I would say that it would be incorrect, because rough titer we never use for the mean, and out of these 3 readings the second reading is little far off, because the concordant reading should be with the difference of 0.1 only. So considering reading 1 and reading 2, we need to find out the difference, and that's the reason we'll take the mean difference of 16.30 divided by 2. So our mean titer is 16.25 centimeter cube. The next sub question is that Calculate the amount in mole of unreacted hydrochloric acid in the solution prepared in step 7 and show your working. Now first let's have a look at step 7. What is written in step 7? It says that filter the content of the conical flask with rinsing into 250 volumetric flask and top up to the mark. Now here this part is important, which says it's the total volume of HCl is 250 centimeter cube and we are asking it's unreacted. Now only unreacted HCl reacted with NaOH after the reaction had completed with calcium carbonate. So it says that the moles of HCl and moles of NaOH will be equal. So first we are finding the moles of NaOH, which is concentration into volume, and here we had calculated the moles volume as 16.25 and the concentration was 1.00. so 1.00 into 16.25 divided by 1000. So here our answer would end up as 0.01625 moles. Now these are the moles of NaOH, but the moles of NaOH is equal to the moles of HCl reacted with NaOH. So that is unreacted, leftover after calcium carbonate reaction. So here the another important part is that we took only 25 centimeter cube of HCl for titration, but the solution prepared in step 7 was 250. So what I'll say is that either we can multiply, so here I'm writing moles of HCl in step 7 is 0.01625. These are the moles for 25 centimeter cube only. So what about 250? So either you can multiply it by 250 and divide it by 25, or at times I'd say that directly multiply the moles with 10. That is the most easier part, because there is a 10 times increase in the volume from 25 to 250. So here after multiplication our answer is 0.1625 moles. Multiplying it by 10 we get 0.1625 moles. Now next is calculate the amount in moles of calcium carbonate that reacts with excess of acid. Use your answer to calculate the percentage by mass of calcium carbonate in eggshell and show your working. Now the other important part is we should know that how much of excess HCl was taken. So the excess HCl taken was 100 centimeter cube of 2 mole per dm cube HCl. That was excess. So first let's calculate the number of moles of these volume. So here let's start with calculating the moles. That is moles of HCl is equal to concentration into volume, which is 2 moles per dm cube concentration into 100 centimeter cube of volume, but we should multiply volume with dm cube. So we are dividing it by 1000. So I'm writing it this way, and our answer for the moles is 0.2. Now this is the total moles. Now moles of HCl that reacted with reacted with calcium carbonate, that should be the subtraction of 0.2 minus 0.1625. That is the moles that reacted with calcium carbonate, because the total moles of HCl taken was 0.25 and the leftover moles of HCl after reaction with calcium carbonate is 0.1625. So after subtracting, we'll get an answer for the moles that reacted with calcium carbonate, and this answer is 0.0375. Now if you look at the equation of calcium carbonate and HCl, here the first equation, we can see that the mole ratio of calcium carbonate up with HCl is 1:2 ratio. So if the moles of HCl is something, calcium carbonate is half of it. So here the moles of calcium carbonate we need to calculate. That is, I will write moles of calcium carbonate is equal to 0.375 divided by 2, because the mole ratio of calcium carbonate is half of the moles of HCl. This will give us the answer of 0.01875 moles. So these are the moles of calcium carbonate. So if you want to calculate the mass of calcium carbonate, that should be moles multiplied by the molecular mass of calcium carbonate. Now the molecular mass of calcium carbonate is 100.1. So multiplying this to 0.01875 multiplied by 100.1, and this gives us the answer as 1.8768. So this is grams. So this is the mass of calcium carbonate present in the eggshell which we have taken. Now let's find out that what was the mass of calcium carbonate eggshell which we had used. So looking at the whole step, it says weigh approximately 2 gram of eggshell, and yes, if we read further here, we found that the student uses exactly 2.136 gram, which is specified here. So then the mass of calcium carbonate into 2.136 gram of eggshell. So percentage of calcium carbonate should be 1.8768 divided by 2.136 into 100, which gives us the answer as 87.9%. So the percentage by mass of calcium carbonate is 87.9% in the eggshell. Now you can always go back, reread the steps, and to find out how did we get this answer, I'll just recall and explain you in short that first we found out the moles of HCl which reacted with NaOH. So these were the moles of HCl that were left unreacted after calcium carbonate reaction. So we found out that which was 0.1625 moles. Now we found out how much of total moles of HCl we had taken at the starting of the whole process, the whole experiment, and we found out that it was 0.2 moles. Now subtracting these 2 moles, 0.2 total out of the unreacted leftover HCl, we get the moles of HCl which reacted with calcium carbonate. Now to find out the moles of calcium carbonate, we use these moles and divided it by 2. Why? Because the mole ratio of calcium carbonate and HCl is 1:2. So we divided it by 2 to find out the moles of calcium carbonate. From the moles, we found out the mass of calcium carbonate present in the eggshell by this formula. We got the mass. Now we found out the percentage of calcium carbonate because the total mass of eggshell which we had taken was 2.136 gram, and so the percentage of calcium carbonate in eggshell is 87.9. That's what we got the answer. Now let's go ahead with the next part, which says name a suitable piece of apparatus which could be used to transfer 25 centimeter cube of solution in step 8. Now step 8 was for titration. So 25 centimeter cube, if we use the apparatus, that should be pipette. Okay, pipette is written. And next sub question says in step 4, a conical flask is weighed using a balance accurate to 3 decimal places and mass recorded. The eggshell is placed in the conical flask and the mass is increased by 2.136 gram. Calculate the percentage error in measuring the mass of this eggshell and show your working. Now there it comes as the percentage error which I was talking to you at the starting of the video, that we should know how to calculate the percentage error. Now if our balance is reading up to 3 decimal places, that is we can read up to 3 decimal places accurate in the balance. So fourth reading, the 4th decimal place we can't read. So the maximum error of our balance reading is 0.0005. That's the maximum error of the reading which we will be using for our balance. So that's the maximum error. I'll add error in our reading. Okay. Now how to calculate the maximum percentage error? Now if we are using the balance twice, why are we using the balance twice? Because first we weighed the conical flask and again we reweighed by after adding the eggshell powder. So we got the balance reading twice. After the difference we got the answer as 2.136 gram. So the twice balance reading we use. So the percentage maximum reading should be multiplied by 2 to get our percentage error. Now how next? What's the next step? We should divide this by the balance reading which we are using for our calculation, which is 2.136 multiplied by 100. That will give us the percentage error. And so the percentage error is equal to, after calculating we get the answer as 0.0468. That's the percentage error we have. So I'm rewriting it here, 0.0468. So let's go ahead with the next sub question here, which says that state the effect on the percentage by mass if the eggshell is not completely dried in step 2 and explain your answer. Now if it is not dried, then the percentage by mass of calcium carbonate would be less. The percentage by mass of calcium carbonate should be less. Why? Because the mass measured for eggshell, mass of eggshell measured will be greater, than the actual value. Now if it is greater than the actual value, that is the 2.136 gram, so because the denominator will be bigger, because the water hasn't dried properly, so mass measured will be more, and so the percentage by mass of calcium carbonate calculated will be less. So that is the main answer. Did you understand? What I mean to say is that the measured mass of eggshell will be greater, and so to calculate the percentage by mass, we divided it by 2.136 gram of eggshell. That value would increase. So if the denominator increase, the main answer, percentage by mass of calcium carbonate, will go less. So that would decrease. Okay. Next sub question is here. The student repeats the method using same apparatus but decides to use 0.1 mole per dm cube of NaOH and reduce the risk of corrosion or damage to eyes. Explain how this introduces a weakness to the experimental procedure. So to get the answer for this, we need to again reread the steps and find out that what was the concentration of sodium hydroxide which we had used earlier. Now the concentration of sodium hydroxide was used as 1.00 moles per dm cube, and now what are we using now is 0.1 mole per dm cube. So this is 10 times lesser concentration. So if 10 times lesser concentration if we are using, then the volume of NaOH required here to react with HCl, which was, this was 16.25 centimeter cube here, 16.25. Now that will increase with the multiple of 10. Because we decrease the concentration 10 times, our value will increase 10 times. That is the volume of NaOH required to react with HCl will be 162.5 centimeter cube, because the value will increase 10 times. So which was earlier as 16.25, now that will become 162.5 centimeter cube. Now this value is too high. This value which is too high to measure by burette. to measure by burette of the capacity 50 centimeter cube, because the burette has a capacity to read only 50 centimeter cube, capacity of 50 centimeter cube, but our reading will be 162.5, which is much higher to measure by burette. Now that will introduce a weakness in our experimental procedure. So this is the main part. Now in this video, what did you learn? You learned how to calculate the percentage error, how to calculate the percentage by mass. So what you used earlier in this is how to be accurate during the procedure, so that you used, because you also found out what apparatus to use. Then you had used the moles calculation and a few more procedure parts you learned. So here is the question 1 of the 2022 winter series of A levels chemistry. I hope this will be very clear, and in the next video we will learn question 2, how to solve question 2.